Wind lifts a thin orange shape across a hayfield, and nobody notices. It rides a seam of air that has no name but summer, then clears a fence, then a road, then the line where crops give way to scrub. The wings are paper, veined and lantern bright. The body is no heavier than a teaspoon of seeds. It advances by fractions, not strides. Here a glide, there a pulse, then a rest among flowers that smell like sunlight. It was born far from mountains it has never seen. It was born far from a forest it somehow knows. As evenings lengthen and the light changes tone, the traveler's body changes too. Engine idling low, reproduction paused. Fat rising under the skin like quiet fuel. The destination is not on any map this animal has read, yet the direction holds. The line is south. The road is invisible. The logic is untraceable. Across fields and highways, rivers and deserts, it threads a continent it does not remember, toward a place that remembers it. Names arrive only after the mystery is underway. The traveler is a monarch, Danos plexipus. And this is the most improbable commute in insect life. Each autumn, a generation that hatches in late summer becomes different from the ones before. While their parents and grandparents lived for weeks, this cohort is built for distance, months of life instead of days, wings hardened for weather, a metabolism tuned to store lipids and spend them slowly. From southern Canada and the northern United States, they set out en masse. Hundreds of thousands reduced to streams, and streams to threads, each thread running southward to a handful of volcanic mountains in central Mexico. There, in a few cool saddles between ridges, the air holds the right balance of moisture and cold, and the oyamel furs. Arbeas religiosa catch morning light while buffering frost. The journey encompasses 2,000 to 3,000 miles, sometimes more. It is an epic without a guide and without a teacher. As a story of animal movement, monarch butterfly migration is both an open book and an encrypted one. The pages list dates and distances, routes and arrival numbers. The key explaining how a newborn inherits a map that no elder can show it is missing. What is known is already astonishing. The travelers fly by day, timing their headings to a time-compensated sun compass, a navigation program that estimates the sun's movement and corrects for it, so that southwest in the morning is still southwest at noon. The molecular clocks that keep time for this compass are not only in the brain. They lie in the antennae, where light-sensitive proteins and oscillating genes turn sunrise and sunset into marching orders. The compass itself is tuned not only to the sun's disk, but to a pattern of polarized skylight that arcs over the day. When clouds close that window, another appears. Under the right wavelengths, short and blue, the travelers can access a second orientation tool, a light-dependent magnetic compass that senses the angle of Earth's field. Both systems feel extravagant in a body this small. Both are necessary because the road is long and the weather is capricious. If this were merely an instance of insect migration patterns, it would already be a wonder of physiology. But it is more, a case where a generation that has never gone south still goes south, where each individual remembers a route it has never flown. The unanswered phenomenon sits at the crossroads of genetics, sensory biology, and behavior. How is navigational information transmitted across generations that do not travel together. There is no learned lecture on the wing, no matriarch leading a column. The autumn flyers, call them the diapause generation, are the great-grandchildren of those who last saw the overwintering trees. Yet they leave when the light falls to a certain ratio, when air cools, and when milkweed declines. They organize not as a single river, but as braided streams that converge toward central Mexico. Arrivals do not scatter across any forest. They cluster in a very specific band between about 2,400 and 3,600 meters above sea level, where temperature and moisture line up to keep them cold enough to conserve fuel, warm enough to avoid ice, and damp enough to prevent desiccation. Lose the canopy, and winter rain can freeze on their wings. Thin the trees, and a cold front can erase a generation in a single night. Still, in intact groves, the insects layer themselves over boughs until the branches sag, and the same mountains receive the same living silk every year. The paradox intensifies in spring. Those that survive the winter stir in March, drop down from the trees on warming days, feed, and head north to lay eggs on milkweed. They do not complete the return trip. Their children, and then their grandchildren, advance the frontier northward in steps, repopulating the breeding range through late spring and summer. The baton is passed 2 or 3 times. Then a signal, photoperiod, temperature, and plant chemistry braided together, writes a different fate into the final brood. Reproduction pauses, lifespan extends, the compass swings south again. This is Monarch generational travel, a journey written in segments, the path south known to a cohort that never had to be told. The animals that left in autumn have vanished by the time their distant descendants are ready to return. There is no caravan memory, no guided tour. The solve must be internal and inherited, yet flexible enough to adjust for wind, mountains, and storms. Nobody knows why the program is this durable when weather and landscape are so changeable. Scientists still debate how much is genetic instruction versus environmental calibration along the way. The result, reliable and delicate, keeps arriving each fall as if the continent rehearsed it overnight. 3 avenues of explanation sketch a map to the answer without closing the case. The first is the solar clock compass complex. Experiments have shown that when the antennae are allowed to track light-dark cycles naturally, migrants orient equatorward. When the clocks in the antennae are shifted, their headings shift correspondingly. Block light to the antenna and the compass drifts. Illuminate them, and the compass returns. In this view, the inherited portion is not a detailed topographic map, but a rule. In autumn, fly generally south-southwest using a sun compass that corrects for time. The fine-tuning comes from the sky itself. The polarization pattern around the sun supplies a heading even when the sun is behind clouds. The internal clocks provide the correction. Neural circuits in the brain's central complex combine these cues into a stable output, wings beating on a preferred azimuth, while winds and thermals are negotiated in real time. This mechanism is robust, redundant, and cheap to copy in DNA. Build clocks, build sensors, wire them together with a compass. It explains why the route is broad rather than razor-thin, and why flocks can fan out across the plains and still converge toward the same mountains. It is elegant, but alone it does not explain how a birth in Minnesota and a birth in Maine somehow share a destination zone in Mexico rather than 2 unrelated southern horizons. A second hypothesis, adds Earth itself to the instrument panel. Under ultraviolet blue light, migrants in flight simulators can orient using a magnetic inclination compass, a sensor that reads the tilt of Earth's magnetic field lines and uses it as a reference when the sun is inaccessible. The candidate mechanism is photochemical. Cryptochrome proteins in the antennae could form short-lived radical pairs whose spin states are altered by magnetic fields, turning a chemical reaction into a compass needle. This is butterfly magnetoreception, fragile, light-dependent, and easily disrupted by the wrong wavelengths. In the wild, the magnetic cue might act as a backup, smoothing headings on overcast days or at low solar angles. It might also help refine south into the south that lines up with home. Yet the evidence, while compelling, remains contested. Replications are difficult, and the field is noisy. Scientists still debate the sensitivity of the system at natural field strengths and the exact tissues involved. If true, it would mean the travelers carry a second inherited rule. When the sky is unclear, trust the tilt underfoot. A third line of work considers the genome and the body it builds. Comparative studies hint that migratory monarchs differ from non-migratory relatives not only in behavior, but in muscle architecture and metabolic pathways. Genes involved in flight efficiency, day-length response, and lipid handling show signatures of selection in North American migrants. The autumn generation's diapause, suppression of reproductive hormones, heightened fat storage, altered stress physiology, is induced by environment, but made possible by heredity. In this interpretation, what is inherited is less a map than a suite of switches. Delay reproduction at these day lengths. Store fat at these temperatures. Prefer these headings at these solar angles. Stop when air feels like this, and trees smell like that. Microclimate selection at the destination. The dark, humid, cold-buffered band inside oyamel fir forests could be guided by sensory templates for temperature, humidity, and topographic channeling by the trans-Mexican volcanic belt. The result is convergence on familiar mountains without any memory of the path, a set of biases that funnels movement toward the only winter that works. The hypotheses mesh rather than fight. A clock-driven sun compass provides the main heading under blue skies. A light-dependent magnetic compass stabilizes it when clouds erase the sun, at least some of the time. Genetically encoded physiology lengthens lifespan, strengthens wings, and records the rules that tie daylight to travel. Along the way, wind drift blurs the track and terrain steers it back. By the end of October, millions reach the same high forests. They layer hillside trees until the trunks look upholstered. When a ray of warmth slips through the canopy, a curtain of orange lifts and the air becomes a quiet storm of wings. When cold returns, they settle in the same dense clusters that conserve heat and moisture. The choreography reads as if instructions were specific. This saddle, these trees. But it likely arises from simple thresholds, meeting a distinctive place. The elegance is in how those thresholds found each other through time. The conservation stakes fold into the mystery. The winter groves survive because fir canopies create a microclimate with temperatures near freezing, but not below, with humidity high enough to prevent desiccation, but not so high that wings ice over. Logging thins the air and raises risk. Warming climbs the valleys and pushes climates uphill, shrinking bands of survivable forest. Storms peel back protective cloud and replace it with rain that freezes. The animals can navigate a continent, but they cannot conjure a climate. If the targets move too fast, inherited rules that once guaranteed arrival will point to vanished homes. The map in the body will have to be rewritten by evolution on a deadline that weather does not respect. Even so, the fall travelers continue to gather, then go. They pass over interstates that do not know they exist. They climb over desert lines that were drawn without wings in mind. They set down in yards and along creek beds, drink from asters, and launch again after wind. The line south is mostly smooth. The river of air holds them, then sets them down. In storm years, losses are heavy. In quiet years, a hillside becomes a single organism made of color and patience. Every arrival is an answer from a question that left the milkweed months ago. Can memory be passed down through blood instead of experience? In this case, the reply runs along the edge of yes. The inherited part is not a diary of landmarks, but a program that turns sky into heading and day length into destiny. A stack of rules that generates a rote without remembering any turn. It is not magic. It is biology so well fitted to the planet that it becomes hard to see where one ends and the other begins. The phrase butterfly navigation mystery hides a set of solutions that are simple in pieces and impossible to explain in full when combined. That combination, the compass that ticks in the antennae, the field that hums under the sky, the genome that waits for a certain length of day, is not only how a species survives a winter. It is also how a small body performs an act that keeps rewriting what we thought we knew about maps. Tomorrow, more will lift from fields that never met their ancestors and fly toward mountains that never met them either. The rest of the continent will go about its business. The line will hold. And in the thin shade of fir needles on a Mexican ridge, a forest will remember their names long before anyone else does.